Hey, this is Varant from Zipline AI, and today I'll be showing you what agentic research looks like on the Zipline platform. So here we have a simple click-through rate model, and in a minute, what I'm going to do is have Codex use the Zipline skill to experiment with adding some new features to this model. So at a high level, what's happening here is Zipline is computing features, some user activities features from this pub subtopic, and some batch features on listings, and using those to power this model that's hosted on Vertex AI. So for example, in this case, you can see what the user activities features look like here. We're doing some sums and averages over these various windows, over these columns. And just to give you a sense of what this looks like in the API, this is the Zipline Python API. And you can see this is where we pointed at this pub subtopic. And down here is where we define the transformations that we want to do over these various columns and over these various windows. So this is what the user or what the agent writes, and that's basically what gets turned into this node here of transformation. And what's nice is that Zipline uses that single feature definition to power both model inference. So that's the real-time updates to the online KV store. That's going to power inference requests for this model, as well as model training. So the backfills that get used at training time, and it's going to guarantee consistency between these two things. So now let's go ahead and experiment with adding some new features to this model. And to make things interesting, let's make them more complex transformations and specifically some embeddings-based features. So let's take the same user activity source and use it to basically create a user embedding and then create a listing embedding down here off of this listings data source, and then compute a cosine similarity between the user embedding and the listing embedding and use that cosine similarity as a feature. And so to do that, I've prepared a prompt here that basically describes that pipeline. And you can see there's a bit of nuance here about like how we weight different user activities, to the impact that these have on the user embedding, and how to compute cosine similarity. And this is important too. These are the various trials that we want Codex to run. So we want to experiment with a few different combinations and permutations of these window sizes. So let's just copy this over to Codex, and we'll start a new chat here in Chronon and set it loose on this. So it's going to use the Zipline skill to run this experimentation, and we'll let this cook for about 10 to 15 minutes, and we'll come back when it's ready. All right, we're back. So Codex finished doing some experimentation, and let's start by actually just following this link here to view the results in Zipline. So you can see here, basically, it gives you a summary of the experiments that we asked it to run, the various windows that we wanted it to try. And the first thing that I'm going to point out here is that each of these are done on their own branch. And Zipline offers a really nice abstraction here for agents, which is this branch-based resource isolation, meaning that every time an agent runs an experiment on one of these branches, there is enforcement under the hood at the infrastructure level to guarantee that this does not interfere with production. So none of the jobs that we run here, they're all resource isolated from production, meaning that it's impossible for it to interfere with production serving of this model. So scrolling down, we can see another sort of visualization of these experiment results. Of course, this is kind of in line with what we expected, given that this is sort of random dummy data. But let's click through anyway to give you a sense of what we see for each of these experiments that the agent ran using the Zipline skill. So the first thing I want to show you here is basically this new graph, right? So this is visualizing essentially the changes that the agent ran based off of our guidance. And you can see in the legend here that these nodes that have this green dot on them are newly created, basically features or newly created, rather nodes in the transformation. And then this golden orange dot here is showing us what's been modified. So notice that these user activity features that we didn't change, these are the same. These are the ones that we were looking at earlier. There's been no modification to these. But what did change is that there's now this, listing embedding pipeline, and now the user activities pub subtopic, there's a fork, right? So it's being used to produce the user activities features that were already there and unchanged. But now it's also going into this user embedding history pipeline that's joining up listing embeddings, and flowing into here. And then demo derivations V6 is where we should be able to see kind of that cosine similarity be applied. So we can actually pop over to that demo V6 and show you kind of what that looks like. So this is some of the code that Codex wrote in this case, and you can see it's basically pulling in these various feature definitions and embedding definitions together, joining them in one place. And then down here, it's applying this similarity feature here using this cosine similarity function. And this is an expression that Codex cooked up as well. And there's a lot of tools in the Zipline skill toolbox to help it write these things, validate them cheaply without running any heavy compute, make sure that the results are in line with what it expected. There's a lot under the hood there that we're not going to get into today. But basically, with this, it's able to define all of these features. So the nice thing here is that this is all you have to review, right? And based off of these features that it's defining here, Zipline's automating all of the infrastructure to do this. And if we kind of unpack what this infrastructure is, right, there's a Flink job to take these user activities, to aggregate them to the last K for each user, to join in listings, to compute that weighted average embedding, to populate the KV store with those, and then to compute the cosine similarity based on joining the listing embeddings and the user embeddings at read time, and to do all of this with real-time updates for inference, and to produce backfills for this that are guaranteed to be consistent with online inference, right? So all you have to review as a user is basically something simple like this, and you can trust the infrastructure that this is production ready. This will run online, and this will serve with low latency and fresh updates, and it will produce basically the same results as what we see here. So, as we see the model results here, you don't need to worry about, silent data errors, things going wrong, the agent having cheated by leaking some future information, and reporting, results based off of that you're not going to see in production, or other scalability issues as you try to launch the streaming user embedding thing to production. You're relying on Zipline to automate that infrastructure effectively. And how Zipline does streaming and batch computation effectively is, again, it's a very deep topic with a lot of detail there. I'm actually going to link a blog post in the video description if you want to take a closer look. It's actually 2 blog posts, one on batch computation and one on streaming. But it discusses how the agent is able to, do this experiment cheaply. Basically, I'll actually show you a little bit of that in the UI in a second here, but as it computes all of these things, how does it do so with maximum compute reuse and feature sharing, while still maintaining resource isolation from production. So to do it cheaply, and how does it also do it scalably, so that as you have these complex streaming pipelines and embedding pipelines, how do we guarantee that serving still works and scales, and maintains latency, really strict latency budgets, as well. And again, you don't have to worry about all that, because if you try to do all of this with an agent without using the Zipline abstraction, without having an API like this, it's going to be writing Flink code in Java. It's going to be writing, some SQL here for batch computation. It's going to be trying to combine those things, maybe trying to run some infrastructure to generate a serving index. And the whole thing is quickly going to become very gnarly, and it's not going to be the sort of thing that you can easily go to production with. So that's one of the main things that Zipline solves for you here. Now down here, I was kind of showing this a little bit earlier. This is basically, some of the experiment results. You can kind of see the new features and how they rank in terms of feature importance, the precision recall curve. Again, this is dummy data, so we don't actually expect it to show anything too interesting at this stage, but this is just to give you a peek at what the experiment tracker looks like. And this is the Zipline native view, but if you have an existing experimentation framework that you want to use and integrate with, it's also similarly pluggable here, so you don't need to use the Zipline one if you don't want to. Same way that the model platform here is pluggable. So I guess I'll quickly show one more thing here, which is just, this is where you can see the actual jobs that were ran as part of an experiment. So in this case, there was this big backfill that was kicked off. And if we come here, I think we should quickly be able to see a few things. And one is that kind of intelligent compute reuse that I was talking about earlier, where basically it's only going to compute the things that it needs to as part of this experiment. And you can see that all of these things here, like the basic listing level features, and some of the basic user level features, these don't get recomputed, right? So it's intelligently reusing unchanged computation from production and only computing things that are new as part of this run. And of course, there's a lot more that you can see here. This is going to load a data sample, in this case, pulling from BigQuery. But again, this could be a cloud of your choice and an existing data catalog of your choice. And you can come here and actually see some of the data. If we click here, we should be able to find the similarity. Yeah, so you can see the cosine similarity features here. For example, the user activity structs that were fed into the embedding, and do some data investigation here. There's a lot more that I'm not going to show in this video, including how we do data quality, drift detection. There's a lot more to the Zipline platform, but today I just wanted to focus on these primitives that we have for agentic experimentation, and how we basically unlock this kind of end-to-end ML experimentation using Zipline, by giving the coding agent of your choice, Codex or Cloud Code or whatever, access to the Zipline skill, which lets it basically offer these things. And the key points are really that you have resource isolation from prod, so as your agents iterate and do more experiments, you're not running any risk of taking down any kind of production serving or production infrastructure. B, you have compute sharing, so as these agents iterate, they reuse compute as much as possible. So if you launch 10 times more experiments, because you have agents running your experiments, you're not racking up 10 times the compute cost. So that's a really important piece of this. I also cut some of that out in the middle when I skipped ahead to the experiment results. It also sort of double checks with the user, and before it runs any kind of big backfill or potentially expensive jobs, it checks with you first to make sure that it's going to do the thing that you intended. And lastly, but certainly not least, the result of this experiment, it's on this branch, and it looks something like this, and it's easy to review. It's inherently reproducible, and more importantly, it's something that you could actually go to production with without having to rebuild a lot of the pipelines to be production ready and to actually be able to serve live traffic. So that's it today. Stay tuned for more videos.